Today, I will be presenting my interactivity and engagement that I will use for my ninth grade scholars at Langston Hughes High School. The three applications that I will utilize will be Nearpod, Desmos, as well as Alex. The Nearpod application allows students to actively engage and interact with my daily activities. The Desmos activity presents students with calculation opportunities to add, subtract, divide, multiply, so forth, so on. And Alex allows students to practice the standards that we will be covering throughout the unit. Currently on the screen, I have my Nearpod application as well as my Desmos graphing calculator. Students typically begin the unit with an engagement activity such as a do now. So for today's, inside of Desmos, I will have students to go ahead and present their problem, which is 40 divided by 5 plus 5 times 2, open parentheses, 13 minus 7, close parentheses. Students are then able to add an annotation to Desmos, to Nearpod of their answer that they came up with from Desmos. Because I don't like the way the pencil wrote on here, I would erase it off, and I would just simply just type it into the text. So according to Desmos, we know that 40 divided by 5 plus 5 times 2, open parentheses, 13 minus 7, close parentheses, would give us a total of 68. Now, when students are asked to move on to problem number 2, they have two different columns that they're working on. And in the first column, they're asked to write each fraction as a decimal. The second row, they're asked to write each decimal as a fraction. The most beneficial part about Desmos is that it allows students the opportunity to convert back and forth between fractions and decimals. So in this case, students are able to go ahead and present 3 over 4 and come up with the answer of 0.75. They can go ahead and edit their application on Nearpod. Where they're able to go ahead and type in 0.75. All right. Moving on, now if we're asked to write 5 2/3, students can also type that in, and they have the opportunity to take a look at the different function settings where they can go in. The numerator would be 2, and the denominator, of course, would be 3. So 5 2/3, we're asking Desmos to place the answer there. So Desmos breaks it down as 17 over 3, which written as a decimal could be 5.66666. So students have the opportunity to then, of course, go in, type in 5.66666 forever how long they would like to. Now, when we're asked to write each decimal as a fraction, students have the opportunity to type in the decimal, and there is an icon that pops up as a fraction where they could go ahead and select it. So now we have identified that 0.7 can be written as a fraction as 7 over 10. as well as they can click the fourth row and type in 3.56, select the icon to identify what 3.56 is as a fraction, and they're able to identify that it's 89 over 25. I am able to then close the annotation and go in from on my behalf to identify what the students came up with for their answers. In order to support my students' vocabulary development for rational and irrational numbers, I will have students to interpret and fill in the blank of the passages of rational and irrational numbers. Therefore, students will get the opportunity to identify between rational and irrational which number cannot or can be written in decimal form or number form. So, as we can see, rational numbers are numbers that can be written as ratio fractions. Rational numbers are decimals that repeat or terminate. Typically, I like to always list examples of what students can refer back to as irrational numbers. So here at the bottom, we have different numbers. So 3, 1.5, 10 over 2, 5.222, dot, 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 11.75, 8.1, with a bar at the top. For irrational numbers are numbers that cannot be written as ratio fraction. Irrational numbers are numbers that do not repeat and do not terminate. So a number that would be considered as irrational would be 3.1415 dot 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 because it's simply not repeating, 9.234983, and 2.718. Each of those numbers are and can be identified as irrational numbers because they do not repeat and they do not terminate. This is where I will provide students with direct instructions where we would convert back and forth between decimals to identify between A to D which number is a rational or an irrational number. So students will find out if a given number is rational. They can check it out with decimals. So one, the number can be represented by the given number as a fraction or integers. The decimal's expansion of the number is terminating or non-terminating repeating. And also, all whole numbers are rational numbers. Once students get an opportunity to go through direct instruction with their teacher, the great part about Nearpod is that it allows students to actively engage. Students will be able to look at a set of numbers. Instructions are provided above. Number one, first students would click on the image to review the different types of real numbers, and then they would place each number to the correct area on the graph. This is a chance for students to determine, based off of the numbers 0, 54, half, radical 11, radical 3, and negative 24, so forth, so on, to determine which numbers are considered to be rational or irrational. This will ensure that students were able to understand the information that was provided to them. So, for example, we can drag over pi because we know that pi has different numbers, 3.14, so forth, so on. We know that 1 would be considered to be a whole number. And this is a fun, engaging activity for students to work on to be able to better understand the type of problems that they are working on. Then they will be given the opportunity to explore different problems. This is where I would typically have students to either work with a partner or by themselves, and they would solve problems, which we would then go over together and then move on to Alex. Any assignments that I typically put on Alex, they are according to the standards that we have covered. Students have roughly a day or two to complete the assignment in class and also at home for homework. So, for an example, the best thing about Alex is that if students tend to struggle, they have different options. They can look for tools help, explanation as to how to solve the problem, as well as an example. The example provides students with different alternatives to how they can actually simplify a number that's listed as a problem. So if we have radical 12, it lets students know that one of the properties of a square root is the following. And it provides them with more explanation to go deeply into details about how students can identify perfect squares. As well as it provides students with the opportunity to identify the answer of what the radical 12 would be. So in this case, if we're working with radical 80, we know that we can simplify that as 4 radical 5. And then students would get an opportunity to go ahead and check their answer. And as we can tell here, this answer is correct. Students can either decide to try another problem or they can move on to the next problem.